All right, so in this video, we're going to talk about trig identity proofs. It's the best part of the class. It's got fractions, it's got trig, it's got everything in it. It's so, in my opinion, it's the part where you really start to show your math skills off. It's where you really learn math. These aren't one-step problems. They're multi-step problems. They're very, very good problems. So now, I'm going to review some terms before we get into it. So if you don't know these, make sure you know these facts because we're going to apply these to fractions and we're going to use them. You know, you have to identify them quickly, okay? The first thing is that we proved earlier in the class that sine squared x plus cosine squared of x always equals 1. And this holds true for any real number, x. So x could be, negative 1,000. It could be 100. It doesn't matter what x is for this equation. All right. I want to show you something fancy just to make your math look cool. I always like showing, little things like this. But so this equation is said to hold true. If you're going to write this kind of in a cool way, this means for any real number x that this equation holds true. So this is the symbol for every or for all. All right, so for every x, and that's the symbol for element, that's the set of real numbers. So any x value that is in the set of real numbers, that equation holds true. Sine squared of x plus cosine squared of x equals 1. Now, it's not just good enough to know this, okay? You also have to know, so let's say I subtract sine squared on both sides. So if I subtract sine squared on both sides, the sine squared, it's moved over here, and we're left with cosine squared of x equals 1. When we move it over, it has to have a minus sine squared of x. So notice that when I go 1 minus sine squared x, I instantly think cosine. And similarly, with the other term, I could subtract cosine squared and send it over there. And whenever I see 1 minus cosine squared of x, that term is equal to sine squared of x. So it's not just good enough to know that sine squared x plus cosine squared x equals 1. You have to know that 1 minus the sine squared x would give you the other term. And the same thing goes with cosine. Cosine gives you the sine. So that's kind of the relationship there. I'll keep quizzing you on that. It's also important to know the basic, the trig identities that were like 1 over sine of x, what that is equal to. So 1 over sine x is equal to cosecant. 1 over sine x is equal to cosecant x. Okay, so you have to know that. 1 over cosine of x is equal to secant x. And also when you see 1 over tangent x, know that that value is also equal to cotangent x. So all of those are important, okay? The last thing that it also is important to know is that tangent of x is equal to sine of x over cosine x. So these are I'm just repeating this. We've already covered these concepts, but again, if you don't know these, you have to know these now. All right, quick question right here. What's 1 minus cosine squared of x equal to? What does that equal? You see that? 1 minus cosine squared x. What do you think of? The c goes with the x, the other one. So this is sine squared x. And remember that 2 right there. That's important. All right, so now we have that. It's kind of a review. Let's get into some proofs. Okay. So number 1, it says prove that cotangent, and I'll use theta instead of x. You know, it's good to switch things up. Cotangent of theta over cosecant theta is equal to cosine of theta. So we're asked to prove that for the first one. Now, whenever I do these, okay, so this is a useful tip. So, tip. You want to write everything in terms of sine and cosine. So, write everything in terms, I would write this down, in terms of sine and cosine. I can't write today. Of sine and cosine. Okay, so that's the tip. Write everything in terms of sine and cosine. What this allows you to do, it allows you to, manipulate your equations in a way that, will work out at the very end. It just is one of those things that you have to do. You have to write everything in terms of sine and cosine. When you do that, it allows you to prove it nicely. So for number 1, we're asked to prove this result over here. Now notice there are 2 sides of this equation. There's a left-hand side, and there is a right-hand side. So there's a left-hand side and there's a right-hand side to this equation. And if we're wanting to prove that it holds true, what we're going to do is, if we're going to try and prove this result, I'm going to start with the left-hand side. 9 times out of 10, I'm going to start with the left-hand side. And then I'm just going to, simplify that result. And I keep working my way down until I reach the right-hand side of the equation. Until I reach that. So I start off with my left-hand side right here. I'm simplifying every step of the way. And what that means is that my left-hand side will be equal to my right-hand side of the equation, and then that holds true. So we don't know that works yet. We're trying to prove that result holds true. So that's what we do with these. Notice that all of my equations are lined up. They're not written here, 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 here. They're lined up, going straight down. It goes straight down, just like that. It makes that noise too. All right. But so that's how you do. That's the setup. All right. Let's prove this thing. I start off with the left-hand side. Here's my left hand. I start with that. I write that down here. Put an equal sign, and then, I'm on my way. Now, recall tan of theta is sine of theta over cosine theta. Tan of theta is equal to sine of theta over cosine of theta. What this means is that if I was going to take this and flip it, I would get cotangent of theta. So if I flip the numerator and denominator, I did the reciprocal of it, I would get cotangent of theta. So if I went 1 over tangent theta, that is really equal to cotangent of theta. And I would flip it so I'd get cosine cosine of theta over sine of theta. So whenever I see cotangent of theta, I instantly think that, and the denominators here, I'm going to write that over here. I instantly think cotangent of theta is equal to this guy over here. I don't even write out all this stuff. This is just scratch work. But whenever I see cotangent of theta, I instantly think, oh, what's cotangent theta? Cotangent theta, I think of, well, tangent of theta is sine over cosine. So whenever I see a cotangent of theta, I think, oh, what if I just flip that in my head? You know, I do the reciprocal of it, then I can write it in terms of cosine and sine. So cotangent of theta is really equal to cosine of theta all over sine of theta. Remember, this division symbol is larger because it's that one. You do that first, and then that's what, so it's important there. Now, cosecant of theta is equal to 1 over sine of theta. So I'm going to write 1 over sine of theta here. Notice I wrote every single thing in terms of cosine and sine now. So I'm doing good right here. All right, I'm going to erase this. Do I put my equal sign over here? No, I don't put it over here. I put it right directly under it. That allows me to keep track of everything. So I'm putting my equal sign right below it. I'm saying this, you know, you imagine it going there. I'm simplifying this term over here. Now what you can do at this point, it's just a fraction problem. So I see right here, you know, there's this 1 over sine of theta term in the denominator. What I can do is I can take it and I can flip it and multiply it on top. So in order to get to the next step, I'm going to rewrite the numerator. So I get cosine of theta over sine of theta. And right here in the denominator, I have 1 over sine of theta. So what I do is I'm multiplying, so I have my numerator here. It's right there. I take that 1 over sine of theta, and then I flip it. So instead of 1 over sine of theta, I have sine of theta over, so I'm taking this, I'm flipping it, the 1's there, so now it's down there. Now, the reason I can do that, and we're to the point in this class where you should be doing that in your head almost, because we're going to be using it so much. So if you don't have that step in your head right now, you're going to get that in your head. But the reason this works here is that I take this value in the denominator and I'm just multiplying it by the reciprocal. So the reciprocal of that So right there, I took this and I multiplied it by the reciprocal of this, and what happened in the denominator is that stuff started canceling out in the denominator, and what happened is, at the end of the day, what's important is that you're multiplying it by whatever this value is flipped. So that's where it's coming from. Now I'm just going to erase this I wanted you to understand where that step is coming from. In fact, we're going to be doing it a little more complicated as far as doing reciprocals, but I wanted you to see that right there. All right. My next equal sign right here. What is sine of theta divided by sine of theta? Well, that number is just 1, right? These cancel out. At which point in time we're left with cosine of theta. Notice what I was trying to prove. This is equal to cosine theta. This value right here is equal to that. We're done. So you can write at the end of the proof, you know, QED or whatever, QED. All right. So that's number one. That's how we would do one. I'm going to show you, 5 of them. All right, so that's number one. Number two. We're asked to prove. So we're trying to prove, I'll write out the whole thing. Prove sine of theta. Actually, I keep saying theta. Let's switch it up. Sine of x times tangent x plus cosine of x is equal to secant of x. So we're asked to prove that. All right, so I write proof. Can I just write that equation right away? Can I write this whole thing to start off? Can I just write it like that? No, I can't write that. I'm trying to prove that, so I can't just write the whole thing to start. So, and I'm gonna give myself a little more space even on this thing. This is a long equation, but so I cannot write that's equal to this. I do not know that. So erase that right-hand side. If you had that, make sure that thing is gone because you don't know that's true. We don't know that is true until we're at the very bottom of our proof. So make sure that that is not there. So I'm going to write it over here so that way I have a little bit more room. Sine of x, tan x. I start off by writing my left-hand side of the equation plus cosine x. I put a little equal symbol. What's my first step? I write everything in terms of sine and cosine. Well, that's sine, so that can stay. Tangent x is sine of x over cosine x. So let's write it like this. Cosine x, well, that's just cosine x. So step one is done. All right, on to step two. Equal sign. Here we have to start dealing with fractions. Okay, so there is no cosine x in the denominator. Also, I wanted everyone to notice one thing, that when I'm doing these, I am just trying to, combine like terms. I'm trying to combine fractions. I don't know what this problem is going to turn out to be at the end of the day. I am just going to go on to the next step here, okay? So that's the other important thing. I don't know what's going to happen with these. So right here, I see a cosine x. I think that, well, let's combine stuff. We have to combine denominators. Let's do that. So right here, I have, there's a cosine x here. I need a cosine x below it. Actually, so I'm going to simplify this numerator up top. Okay, so all I did here was I took sine x times sine x. That's equal to sine squared of x. Now, plus cosine x, but I need it to have the same denominator in order for me to combine stuff. So I have this cosine x right here, but I need it to have the denominator cosine x. It has to have that down below. Now, in order for this equation right here to be equal to that, I have to multiply it by cosine x up top. What this allows me to do is cosine x over cosine x. That number is really just 1. So I have 1 times cosine x, which is equal to just cosine x. So it's that. So it doesn't affect anything. So doing that did nothing to the equation from here to here. So if I was going to take that term right here is equal to this. Now, I'm going to write this a little differently. So, because cosine x times cosine x is really cosine squared of x. So, instead of writing it like this, I'm going to write cosine squared of x like that. That's not too big of a step where you can jump from there to there and you can see cosine squared of x divided by cosine x is cosine x. So, that's okay as far as, not showing every single step. You don't have to show cosine x times cosine x right there. That's okay like that. Next step. It's important to show your work, though. Cosine x is in the denominator. So I put a big old fraction symbol. I'm combining the fractions. I have cosine x down here. I combine them. There's 1. The numerator, I have a sine squared x and I have a cosine squared x. So I'm going to write sine squared x up top plus, there's my cosine squared of x. So all I am is I have a common denominator. I'm writing it right down there. What's sine squared x plus cosine squared x? At the beginning. It's coming back, isn't it now? Sine squared x plus cosine squared. That's 1. That's the number 1. So this really is equal to 1 over cosine of x. Notice when I did that, when I was simplifying it, I didn't write, sine squared plus cosine squared x is equal to 1 like that. Because what happens is you're combining your equations. You can't really do that with the numerator. It doesn't make sense. You're looking at the whole entire expression here. So this numerator, I'm just writing it as 1 right there. I don't write it equals 1 right there. That would not be correct right there. So we're doing this correct. You don't want to write off stuff. You don't even want to write it off to the side. You're just taking that value and you're putting a 1 right there. Now at this point in time, I'm like, well, we simplified this thing pretty good. We're at a point where we simplified it pretty good. I look up top. I see my secant x up top. And I start thinking in my head, well, how can I make this look more like that? Well, 1 over cosine x is equal to secant x. This value is equal to secant x. So that means we're done. So we proved this is equal to that. We proved this is equal to that. So then that means we're done. So quit. End of proof. Number 2. All right, let's go on to number 3. You know what? I'm just going to do the first 3. The other, 4 and 5, I'm going to have you kind of work on those, okay? Try your best on those ones. On number 3. Number 3. It says prove 1 minus secant x over 1 plus secant x. That this is equal to cosine x minus 1 all over cosine x. plus 1. The proof, so I write proof. I keep writing PF, I could write out proof. All right, start off. Rewriting this. Not the whole thing though. All right, I'll help you to get started. So that's the first step. I would pause the video and I would try and see how far you can go on this problem. If you just wrote this here, you want to remember not to do that. Okay, so if you did that, make sure you're not doing that. You don't know that this is equal to that. So that should not be on your paper yet. You're trying to prove this is equal to that. You can't just write it to start. So don't do that. So right here, I have this. The first thing you want to do is write everything in terms of sine and cosine. So I write 1 minus secant x. What is secant x? That's 1 over cosine x. So I'm going to write 1 over cosine x. All over secant x. 1 plus, what's secant x again? 1 over cosine x. All right, now I have this. Okay. Now, there's a couple of ways to do it at this point. One, I'm debating what to do. Well, one way is we could multiply the numerator and denominator by cosine x and see what happens. But the other way, we could just, combine, find a common denominator there and just see what happens to it. It doesn't really matter what we do. So right here, 1, I'm going to look at the numerator and denominator here. And also these might not work out necessarily. When I do these, I have no notes or anything, but sometimes I might backtrack, okay? So I have 1 right here. So this value is really cosine x over cosine x minus 1 over cosine x for the numerator part. The reason I'm doing that is to get my cosine x term down there. Now I have 1 plus, and also instead of writing 1, I'm going to write cosine x over cosine x. Because that's the number 1 right there, cosine x over cosine x, and then I have a plus 1 over cosine x. I like how I did this. It's a good way to start, introducing you all to dealing with fractions again a bunch of times. Because what I'm trying to do here is I'm trying to take my numerator and I'm trying to find a common denominator, and also with this denominator term, find a common denominator there. All right, so at this point I have this. All right, cosine x minus 1 up top. All right, so I have cosine x minus 1 up top. I have a cosine x down in the denominator. And now I'm dividing that whole thing by cosine x plus 1. All divided by cosine x. I know I'm kind of running out of room right here. I hope you can see that here. I might, I'm gonna erase this. See, and this is why it's good to write on a piece of paper, because when you're going down like this, it's very rare you're gonna run out of room on a piece of paper because you just flip over to the next page. On a whiteboard, you actually run out. So right here, you have cosine x plus 1 all over cosine x down here. Here, I'm gonna write it just a little. Cosine x down there. Okay. So I have this. Make sure that division sign goes all the way over. Okay. Now, at this point in time, so keep working down, but I'm out of room, so I'm going to kind of, I'm going to do this. I'm going to rewrite this a little bit. cleaner. So make sure you keep on going down. I'm going to say this right here is equal to this. I'm just going to write this over here. Okay, so we have some stuff. And then we have we got to the point in our proof where we had cosine x minus 1 over cosine x. And then we had all divided by, this division symbol was larger, cosine x plus 1 over cosine x. I'm rewriting this here. So we made it here. Now, at this point, what I'm going to do is I'm going to take this value here, I'm going to take it, I'm going to flip it. So I'm going to multiply it up top. So I get this is equal to cosine x minus 1 over cosine x. I'm taking my numerator here. I'm rewriting it down here. When I look at my denominator term, that has to flip. So I'm multiplying it. I stab it right there. I'm multiplying, and I'm taking this value in my denominator, and I'm taking it, and I'm flipping it. So right here, cosine x is down below. So now it's going to go up top. So it was down below. It's up top. Look at my middle finger. My middle finger is here. It's now up top. All right. If I look at my pointer finger, it's up top. Now it's going to have to go down below. So it's going here, down below. So it's cosine x plus 1. It's from there, taking it and flipping it. Well, that's nice. The cosine x terms are canceled. And what are you left with at the end of the day? You're left with everything in terms of cosine. So I have cosine x minus 1 all over cosine x plus 1. All right, at this point I'm like, well, what else? What else do we have to, can we simplify it anymore? What were we trying to prove? Oh, we were trying to prove that. So I look up top. I noticed that this is what exactly I was trying to prove. I'm going to erase this a little bit. I was trying to show this left-hand side right here. This is my left-hand side. This is my left-hand side. This is my right-hand side, RHS, right-hand side, RH, hand side, right there. This is my right-hand side. I have my left-hand side equal to my right-hand side. This term is right there. That means I'm done. So, quit. End of proof. Okay. So that is how we deal. I wanted to introduce you to that. That's how we start dealing with these things. All right. Hope you thought it was as cool as I did.